Hi, in this video I will explain how to tell if two parts of a circuit are in series or parallel and how being so affects the current volt of the circuit. These two resistors are in series with each other. You can see that one end of one is connected to one end of the other, and there are no other connections or branches in between them. In a series circuit, when you have two resistors in series, the same amount of current flows through both resistors if they're in series. Think of the current as like water, and if this was a water pipe, then the same amount of water is flowing in this part of the pipe as it does in this part of the pipe. The resistors are not changing the amount of current or the amount of water. They're changing the energy of the current or the energy of the water if you think of them as a waterfall. They're changing the voltage of the electrons that flow through them. The resistors decrease the energy and the battery increases the energy. These two resistors are in parallel with each other because you can see that one end of the first one is connected to one end of the second one, and then the other end of the first one is connected to the other end of the second one. So we call that being in parallel. When resistors are in parallel, they do not necessarily have the same amount of current going through each. You can see that there's a lot more current going through this one than there is through this one. That's because this one has a higher resistance value than this one, and the current takes the path of least resistance, most of it does. But what I want you to do is think about this current as water. If you think about that current as water, then you'll see that right here it's kind of a fork in the river. So the amount of water that goes this way plus the amount of water that goes this way, it has to equal whatever water was in the main branch. And then when the water goes through the resistor and goes through this resistor and comes back, this amount of current is the same as it was originally. Like the two forks in the river join back up. So this is all the same amount of water in the circuit as a whole the entire time. The battery does not add water and the resistors don't take away water. What they're doing is not changing the current, they're changing the energy of that current, or the voltage or electric potential of that current. The battery increases the potential and the resistor decreases the potential energy. So you can think of the water, if you want to think of the water analogy, then you would say that the battery is sort of like a water pump and the resistor is sort of like a waterfall. So these are two waterfalls that happen to be next to each other. They have to be the same height because the water starts at the same height when it forks, and it's at the same height when it comes back together. They're just, one has more water going through it than the other does. Or you can think of it as the battery is sort of like the up elevator that changes the height, and the two resistors are sort of like two different staircases. So they might both be staircases that go from the second floor to the first floor, but they both start on the second and end on the first, and the battery starts at the first floor and ends on the second. One quick thing to look out for: always go with the definitions of series and parallel and how the resistors are connected to each other, not the physical shape of the circuit. Here is an example of two resistors that are physically parallel to each other in the circuit, but they're actually in series because you have one end of one connected to one end of the other. Just a tip. Bye.